Hi, I'm Filip Biały, and this is a lesson about the types of machine learning. Thus far, we have discussed different definitions of AI and machine learning and also covered some of the history of AI research. Now, we need to discuss the following questions. What are the three main types of machine learning? How does each of the types of machine learning work? And what is deep learning? And what is its relationship to machine learning in general? So let's start with the three types of machine learning. The first type is supervised learning. Supervised learning is about using examples labeled by humans and an algorithm that learns to recognize new instances of the same class using those examples. So we have something that is called training data, which consists of items, elements that are labeled by humans, and something that we call test data. Training data is used to teach an algorithm and model how to recognize those elements. And test data is the data that algorithm has not thus far seen, which means that it will use some of the patterns it learned from the training data to recognize similar elements in the test data. And one example of such algorithm could be image content recognition. We show to the algorithm examples of some images, let's say cats and dogs, and the model is trained, which is able then to recognize which of the types of images it sees. So if we will now present to the model a set of images with cats and dogs, it will be able to recognize using some statistical patterns whether the picture in question is a picture of a dog or of a cat. And supervised learning requires human intervention. It requires human labelers that will label the images, for example. The second type of machine learning is unsupervised learning. And here, algorithm finds patterns in unlabeled data, and it divides it into categories of similar items. So it can be used to cluster the elements in the dataset without intervention of the operator. For example, it could be about finding segments in consumer dataset. So it is about recognizing some similarities between the elements within the dataset. And then we have reinforcement learning. Reinforcement learning is about algorithms learning to work properly from the feedback in the form of rewards or penalties they receive from the environment. So based on the action taken by the algorithm, it will either be rewarded or penalized. It means that based on that feedback, it will be able to optimize itself. And one example could be a chess playing algorithm. Depending on whether the move it suggested is good or bad, it will receive feedback from the environment. And if the feedback is positive, it will learn, well, that is the move that I should be making. And if the feedback is negative, it will say to itself, and it will learn, well, it means that I need to correct the algorithm, the model, and so on. But let's take a closer look at those three types of machine learning and start with supervised learning. In supervised learning, human supervisors label the elements of the training dataset as examples of desired results. So let's say that we have some training data and human labelers that will describe each item, each element of the training data. And here an example could be a dataset of different shapes. So we have circles, we have triangles, and we have rectangles. And each element is labeled as such. And of course, those circles, triangles, and rectangles could be of different size, of different color, but they nevertheless either of those three shapes. And human labelers will describe each as properly named shape. Then we have the classifier algorithm that will be responsible for recognizing the data. And based on the examples it received, it should be able to then categorize, classify the test data. The test data is a data set in which we also have different shapes, but they are not described as such. So, in principle, the algorithm should not know which one is which. But based on the patterns it learned to recognize from the training data, it is then enabled to understand and to classify those different shapes and put them into separate categories. Of course, none of the machine learning methods is always 100% correct. So it is always with some degree of probability it will recognize the contents of the test data. And therefore, for example, in the output we may sometimes have some incorrectly recognized data. But in general, the mechanism is quite simple. It's based on the input, both in terms of the training data and the test data. A slightly different story is with unsupervised learning. Here, the learning process does not require supervision or training dataset. In this approach, we have input data, and it again could be a set of different shapes. We have a process of interpretation, which is actually the use of an algorithm that tries to find some similarities between the elements in the dataset. And it is then clustered, which means that those similar objects are being put in separate subsets of similar objects. And again, the similarity between those different objects, different elements, is based on some statistical patterns, which may sometimes mean that there will be some errors in the clustering algorithm. But in general, it will lead again to generating output in which those three categories in this example will be divided. Yet another story is with reinforcement learning. In reinforcement learning, the learning process is based on the feedback from the environment. So here again we may have some input data, but it will be then processed in the following way. First, based on some policy, which are the rules according to which the agent, which in this case could be a machine learning model, will operate, define the path it will follow. So it will choose some algorithm that will be responsible for classifying objects in the dataset. And based on that algorithm, an action will be taken. That action will then be transferred into the environment. And the environment in this case will be a set of signals in which the algorithm, the model, will learn whether it is doing well or not. So it will receive either reward or penalty. And if it is a reward, it will say it is a correct course of action. It is correct algorithm. But if it is not correct one, it will need to make some adjustments. And here the learning process has this iterative character. It is iterative because based on the signals received from the environment, the algorithm will optimize itself, and in the end it will be able to produce some output. So we have those three approaches to machine learning. And these three approaches can utilize different methods. So it is also important to understand that machine learning in relation to artificial neural networks is a more general category. All types of machine learning use many different methods and techniques. Some of those techniques are taken from statistical learning or Bayesian approach and so on. Others rely on artificial neural networks. And artificial neural networks are loosely based on the brain's neurons and consist of multiple perceptrons that form different layers of a network. Each perceptron takes multiple input signals and it performs some computation and then produces an output. And multiple perceptrons are combined into artificial neural network. And only then, when they are combined into such a network, and especially when the network has multiple layers, it is able to produce some amazing results because it uses multiple different approaches to computation and therefore is able to come up with some impressive results. And whether the task is to classify something, to recognize an image, and so on, deep neural networks, which consist of not just two layers, input and output layer, but also of some deep layers, hidden layers, they are able to achieve the results that we know today from advanced machine learning models. Deep learning, therefore, is a subtype of machine learning that relies on neural networks consisting of multiple layers, including those hidden layers. Most of the recent developments in AI are connected to advancements in deep learning. So whenever you will see in image recognition algorithms or generative AI, they usually utilize deep learning. And deep learning is this approach to machine learning which made it so successful in the last 2 decades. So to conclude, main types of machine learning are supervised, unsupervised, and reinforcement learning. Each type relies on different architectures and methods, including artificial neural networks. And deep learning is a subtype of machine learning that utilizes multi-layered neural networks. So here we have a brief picture of machine learning, and machine learning as the main contemporary main field or subfield of artificial intelligence is something that is almost synonymous today with developments in computer science. And when you think about it, actually the history of AI, of developing intelligent machines, is almost the same as the history of computer science itself. So the progress in AI is something that we need to observe very closely, because it will reveal maybe some future of computer science as a field. And in the next lesson, we will speak about predicting future of ICT and computer science. So thank you so much for now, and see you very soon.